Hello everyone, in this video I'm going to find the Maclaurin series for sin x. So we're going to find the first four non-zero terms for the Maclaurin series of sin x. Previously in the last video I explained that the series of the form a naught plus a1x plus a2x squared plus a3x cubed and so on. So this is called Maclaurin series, and here any coefficient a n is given by nth derivative of the function evaluated at 0 over n factorial. So in other words, you can say that the series is of the form, so a naught is just f0, a1 is first derivative 1 factorial, second derivative 2 factorial, and so on. So I'm going to do a table setup so that we can find all the coefficients a0, a1, a2, a3, and we can plug in our function. Column we will write our n value. Second column we will find our derivatives. Third column we will find the derivatives at 0, and in the last column we're going to write our coefficients of our each term. All right, so when n is equal to 0, so we have our original function, which is sine x in this case. So sine x, and the value of sine 0 is 0. So these x values are in terms of radians, so just be careful. So a naught is, so function value at 0 over 0 factorial, which is just 0. Next we have n equals to 1. So first derivative of sine is cosine x, and then cosine 0 is 1. So a1 would be, so the value of first derivative, so this value, so that is 1 over 1 factorial, so which is just 1. Then we have, so n equal to 2. So second derivative is, so derivative of cosine is negative sine x. So negative sine 0, which is just 0. So a2 is 0 over 2 factorial, so which is just 0. And then we have 3. So derivative of negative sine is negative cosine x. So negative cos 0 means negative 1. So a3 would be negative 1 over 3 factorial. And similarly, we can have, so derivative of negative cosine is positive sine x. So sine 0 is 0, and a4 is 0 over 4 factorial, which is again 0. So we notice that so far we got, so this is 1 over 1 factorial. So first term is 0, first coefficient is 0, then we have 1, then we have 0, then we have negative 1 over 3 factorial, then we have 0. So now let's find one more. So derivative of sine is cosine x, and cosine 0 is 1, and we got 1 over 5 factorial. So 1 over 5 factorial. So if we try to notice the pattern, so first we had 0, then we had 1 over 1 factorial, then we had 0, then we have negative 1 over 3 factorial, then 0, then we have positive 1 over 5 factorial. So again, next we're going to get 0, and then we're going to get negative 1 over 7 factorial. So we are getting alternatively positive and negative signs, and we are getting all the odd, like 1 factorial, 3 factorial, 5 factorial, 7 factorial, and all for all the like terms with the even factorials, they are 0. So let's plug in these values in our function. So using the values of all these coefficients, so a0 is 0, a1 is 1, a2 is 0, a3 is negative 1 over 3 factorial, a4 is 0, a5 is positive 1 over 5 factorial x raised to power 5, and then 0 x6 plus, so again minus 1 over 7 factorial, x raised to power 7, and so on. So we got that sine x is approximately equals to x minus x cube over 3 factorial plus x5 over 5 factorial minus x7 over 7 factorial. So these are our first four non-zero terms of sine x Maclaurin series. And if you want to write like all the infinite terms, so you can see the pattern that we have. So n from 0 to infinity, and so negative 1 raised to power n, so x raised to power 2 and plus 1, so only the odd powers, and then factorial of odd numbers. So this is how we get our Maclaurin series. I hope that makes sense. So if you like this video, please hit the like button and subscribe to my channel. See you next time.